But it's going to delay your program.
Sorry?
It's going to delay your
It's
program.
going to delay a little bit.
Sure, sure.
We're still, we're still trying.
Good. All right. Sure. It's good. Lovely. Can you?
Good.
Okay. Am I audible? All right, ladies and gentlemen, thank you very much for coming over. And the topic of the day is harnessing the power of GenAI in automotive. Both these are nothing new. It's been happening for some while. Before I get into my presentation, a quick overview on the organization that I represent. So our company is Ignitarium. We look at the engineering R&D services. We are headquartered in India, but we do have a presence in Munich too. And apart from that, we do have global presence covered by US, Canada, and even Japan. Now, what we do, we are divided in two parts. One, the semiconductor side of it, where we look at the SoC design, FPGA, RTLs, and other things. And then, of course, the software portion, which is all about your embedded AI as well as the cloud aspects of it. The technologies or the domains that we cater to are four different areas: automotive, robotics, industrial automation, and of course the consumer segment. And if you want to know more about us, do visit us at hall number 5156. We are actually showcasing a couple of demos, one on a Renesas platform, where you have a autonomous mobile rover, and then the second on the Qualcomm platform, a drone-based system using AI for a rail detection. Now, let's start with the topic that we have. What if I told you that the most important part of the next car wouldn't be your engine, battery, or even the wheels? We spent decades perfecting the car's move, but have you spent enough time thinking about cars? Imagine stepping into your car and before you even speak, it knows you're tired, and then it does all what is required kind of thing. And the last, over 90% of the automotive innovations today are software driven. Now, anyone can guess what is the commonality between all these four statements? So this is the power of GenAI. I gave a prompt to ChatGPT asking it to say, okay, give me 4 different ways of presenting a particular topic. And it came up with 4 different options. So you could see that whether I need a bold visionary approach, do I need a thought-provoking statement, do I need a storytelling mode, or data-driven factor? This is the power of GenAI, and welcome to the era. Let's delve a bit into the timelines, where it started, how it proliferated, and other things. As you all know, November 2022, that's when the OpenAI's ChatGPT got released. And that was the 3.5 version. And within about 2 months of its existence, the entire, they got close to about 100 billion users in 2 months. That's a massive achievement that they had. Slowly but steadily, you would have other guys catching up with Meta's Llama that is coming up in Feb, followed by in March, you had OpenAI themselves releasing ChatGPT 4.0, Anthropic coming with Claude, as well as Google in terms of the Bard. April again, Amazon announced the Bedrock part of it, and so on and so forth. And the most recent one is the DeepSeek one, right? Where it is now challenging in terms of the amount of training or the cost that is required to achieve almost similar what OpenAI has achieved. Traditionally, if you look at an ML model, what does it do? So you have the data part of it, you have a label part of it, You give this into the model, which is your predictive ML model, and all it does, it learns the relationship between the data part and the label part. And because of it, it's able to create the outputs. How is GenAI different from this? Here, the input is not the data and label, it is an unstructured data, and huge amount of unstructured data is fed into the system. Notice the difference. It is not the relationship it is looking at, it is the pattern in which the unstructured data content is created. It is trying to figure out what pattern it is created. And because of this is where the power of GenAI comes, where it is able to create the creative content, which is not existing before. We touched upon the GenAI part of it, and since the topic is on the automotive, let's quickly look at what the automotive field has been. Traditionally, it started with the mechanical part of it, the good old 18th century, the steam vehicles. And then 19th century was all about combustion, gasoline, the factors, the enhancements over there. And then came the modern cars, right, which is in the 21st century. This is where we saw that, okay, there were luxury segments which had ADAS-related stuff. High-end cars used to have, or they praised to have in terms of AI inbuilt into it. And that's how the technology moved. Later, we saw that, things like EV, which was a segment for last year, saying that, okay, people want to move away from gasoline, get into EV segments and other things. But now the trend, if you look at it, is mobile phones have been there in the market, and people want to move away from a pure mechanical kind of thing. And we call now mobile on wheels, right? That's the new concept of the cars that we're coming in. What does it mean? It means that I just want to have one hardware, but I would want to differentiate in terms of creating the software which is required to actually enhance my whole system. Sorry, there's a screen just popped up. Yeah. So when I say mobile on wheels, the way it comes is, of course, I have multiple sensors on my car. It could be multiple cameras, LiDARs, LiDARs. And then each of these cars have become more and more smarter. Complexity, of course, has increased because you are now talking about multiple sensors, sensor fusions coming into place, and complex kind of algorithms that are running. All this has increased the complexity. And most importantly, because now we are talking about too much of software that is in play, right? Safety and security becomes a paramount aspect. Gone are the days where these are secondary aspects. Now, because of the proliferation of the software, safety and security is at most. And we are talking about V2X, V2, all kinds of connectivity a part of it, which means vulnerabilities have to be plugged in. Hence, you can see that, AI at one point was a luxury segment, but now going on, AI is now a necessity. Some recent developments that happened. December 23, Audi and Reply partnered with AWS to actually improve the enterprise search, and that was based on the GenAI chatbot. In 24, Qualcomm and Alphabet announced a strategic partnership for the advanced AI-driven. In December 24, Waymo, most of the guys would have known that they were operating in San Francisco. They expanded their whole thing to Phoenix. That's because they are more confident that this whole thing can work seamlessly, and that's the future they see. And of course, recently in Jan 25, Intel has announced something called an adaptive control unit, specifically targeting for the ECU segments, EV segments, and they want to get into zonal and other architectures. Some market insight, I'll not go into detail. These are all data that is there from McKinsey's and others. So they did a research in terms of the generative AI's impact. So they feel that it could add trillions. The numbers are huge. And what has happened over the years is there is a median that they had come up with, saying that, okay, for us to catch up with GenAI and technology, the initial median was somewhere in 2060s and 2070s. With the proliferation of GenAI, now the new statistics is that by 2030, most of the organizations will have GenAI in place. Another set of data points. Global GenAI today in automotive is 514 million, and this is supposed to grow to 2,600 in 2032 with a CAGR of 22.5%. That's a staggering amount, which means that everyone who's looking into building things, this is most important for them. Now, we all know that the growth is actually done by two things. One is the rising demand of the AI-powered. As I said, right, AI is no longer a luxury segment. It's more of a necessity, which means everyone has that in their cars. Second is, even in terms of manufacturing process in let's say, the BMWs or the Mercedes of the world, when they create a smart infrastructure for their, let's say, factory floor and other things, this becomes a most important factor where they can ensure that productivity losses are minimal. And we know that there is a high implication in terms of cost and privacy. That's something that we'll dwell upon. Now let's go through some of the benefits of GenAI, especially in the automotive, right? So one, it is going to be creative and innovation. Why do we say that? It unlocks new possibilities in content generation, be it code, be it text, or it could be any designs. Brainstorming and refining ideas by providing diverse perspectives and enhancing problem solving by generating multitude of unconventional solutions that are there, facilitates rapid prototyping. Okay, all this is English. Now let me give you a use case of this. Assuming that I am the product owner for HMI, and for a new car segment, I'm going to define a new set of parameters or new look for my HMI screen. In the traditional days, the way that I would have done is I would have sat with multiple designers, shared my idea, and they would come with certain set of parameters, a lot of tweaks that would have gone through, and then finally we arrive at a code. Once we're all good, we actually generate the code, write the code, and then move on. Come GenAI, what happens is I can give this feed, I can give the parameters, I can say these are my constraints, I can feed this to a model and say, look, here is what I want, and I don't want the conventional way, I want something new. And this is where power of GenAI in terms of designing the entire screen for me. Now the advantage is this cycle is going to be very, very short when compared to the earlier one. Plus, I can also take it to the next level where I can then ask it to generate code for me. It could be in templates, it could be some factors where I can reuse. That is what the power of the GenAI is. The second thing is about scalability. Assuming that, of course, in the previous days, if you want a scalability part of it, it's all about having additional manpower, right? The more you want to scale, the idea you would want to do is put additional engineers who would work on these solutions and get this all working. The same case that we did, we had an HMI which was, let's say we built it. Now, I'm going to, let's say, produce this car or market this car, which is region specific. And each of the regions have got language as one of the barriers, right? If I have to change my entire HMI screen in terms of a language specific, then the amount of engineering effort that it takes is huge. I will have to have more and more manpower, which is required to change this whole thing. This is where power of GenAI is. All you can do is feed this. The same screens are generated in multiple languages. It is consistent, and it is faster. The third one is in terms of efficiency. Of course, automates most of the repetitive tasks that we see, and that's the power of GenAI. It reduces development time by generating high-quality code, which we already discussed. And the third one is improves decision-making by synthesizing and then, collating the data that we have. Imagine the same case where we have designed the UI, we went to the process where we have it in multiple languages, and assuming that there's a new standard that I have to cater to. It could be cybersecurity, it could be any functional safety. And these standards are, let's say, 1,000 pages of information. An engineer who has to literally go through these pages, understand what it is, come back and tell you that, okay, here is my problem, here are the things, the constraints that I need to take care, is going to be quite tedious, time-consuming. Now, if I feed this whole 1,000-page document and ask GenAI to literally tell me, okay, what are the 10 things that I need to take care? Give me a list of all the things that I need to take care in the software. Here is my software, what is applicable, what is not applicable. It reduces your time drastically in coming up with a shorter pitch and more effective one where we could only concentrate on this and get these things done. That's the efficiency that we're talking about. Last but not the least, in terms of ease of access. Why do I say ease of access? One is GenAI brings you all into a single table where I don't need to understand the technology aspect of it. Even any regular engineer who doesn't know anything about AI can actually go ahead and then probably run these tasks with the same efficiency as any other AI engineers. Assuming that you have let's say you have a luxury segment car and you run into a problem. Now, one way is you go to these specific dealers who know how to rectify it and put it across. But let's say you have a power of GenAI where you have a tablet, and with the tablet, I'm able to capture multiple sensory data. Let's say I take a shoot of an engine. I'm able to give it the voice that is coming up. I'm able to set the context that is there. With this, GenAI can tell you, okay, here is the problem that I have analyzed. These are the 4 parameters that you need to check and figure out if this is the issue of that. So diagnosis becomes faster, easier, and it doesn't have to be specialized. This is an area we see that for ease of access, people embrace the GenAI part of it. So I spoke about the general use case and other things. In our organization, at least, there are a couple of threads we have seen where things are picking up. One is, of course, the voice assistant. This is there in most of the cars, and it's coming up in the future. The left side that you see is a complete cockpit that we had demonstrated. You have a cluster, you have an IVI, and then the right is nothing but your rear seat entertainment screen, all running in an SDV kind of environment powered by NVIDIA with multiple ECUs like a TDA4 or an NXP gateways sitting across. Now, what I've done is I've just taken that whole IVI window into this part of it. The use case that I will shortly demonstrate is you have a voice assistant, assuming that, let's say we run through a use case. I get into a conference, and then I've driven from home far away, let's say an hour's drive. I reached the conference, I've spent the whole day there, and in the evening I'm really tired, and I just want to go back to my home. Imagine a case that the minute I get into the car, if the car is able to figure out that, look, I look very tired because anyway you have the camera systems in place, it is able to tell me that, do you want to go to your home as a destination? I don't have to set the navigation. It automatically does for you. And it starts, and then we are on the journey. Now, because I'm tired and it knows that there is a route that it has chalked from the conference to the home, let's say I'm very drowsy and sleepy. Now, what happens is a DMS system, which would look at your driver part of it, kick in. You would know that, okay, the eyes are drowsy, you have micro-sleep patterns and other things. There are triggers that are being generated. What if this system can feed it back to an LLM or a voice assistant, wherein my voice assistant is able to understand that, look, okay, this person is sleepy, and the best way to do is maybe a coffee break. So can I modify the navigation automatically, saying that, look, I know that your favorite is maybe Starbucks, and on the route, I would modify the route in such a way that I go to a point, Starbucks as one more destination that gets added into the system, and then take care of the whole navigation. So all this is done seamlessly without even me touching a button and then putting across kind of thing. So let me quickly run through the demo and put that across. So hopefully you should hear.
Hi, I'm Nova, your music buddy. Tell me what's on your mind.
Yesterday, I went to watch my favorite team play football, and the team won by 2 goals.
That's awesome. You must be feeling pretty proud of your team right now. What was going through your mind when they scored the winning goal?
The was really awesome since we topped the table now.
Based on our conversation, you seem to be happy. Playing a song from Happy List.
So what you just saw here was a smaller demonstration wherein when I sit in the car and I'm having a conversation, it is able to judge what kind of mood I am in, right? And then based on the mood, it is able to automatically change my music playlist. This was just for a demonstration that we had. Moving on, the next one, the second use case that we see is in terms of optimizing the software development, especially on the validation side of it. You can see the right is a famous V model kind of thing, which means you have development on one side, validation on the other side. But what happens generally is you spend a lot of time in terms of validation. And that's because you have to generate a lot of test cases. You have to understand how to generate these test cases. And sometimes it is just a mundane activity because you have a code and anyone can generate it. There is no, you don't have to have in-depth knowledge of it. Imagine if a system could generate this for you rather than us. So the next demo I'm going to run is more from that perspective. So what we have done is you have, let's say, a technical reference manual. This reference manual is then broken down into multiple sections. And I can select a section of interest for me. For example, let's say I have a boot, which is in the section. I just select one of the section. And then on the left side, if you see the prompts, I would say I need a test objective. Here is my prerequisite. This is a test design, test procedure, and I need the test to be delivered in this fashion. What you will see next is that the LLM is able to run this. So we can quickly see the SD cardboard is here taken as its context. I have set these as the template for the prompt. I do a submit here, and voila, you would have the test which is generated. So literally, you can see that the entire test where I have said that I need the objective, request, the design, procedure, as per this expected result, the same way the output is being generated. This actually helps you in terms of the amount of time that is required for you to generate these test cases. We see a drastic amount of differences that are coming in, and that helps up in the overall time. So this is the test document that it generated. You could see that the section was 5.4.3. Here's the test case, and there's a bunch of test cases. I've just taken one of the test cases just for the reference part of it. You have an objective, you have a prerequisite, you have a test design, you have a procedure, and what is the expected result. Now you could take this to a next level where I could feed this into the system and tell you that, okay, can you generate me a code? And I could have multiple code generators. I could have a C++ code generator or a Rust code generator. I could just plug in those modules to ensure that this is all working kind of thing. Not everything is rosy. Of course, there are challenges, considerations in adoption. And let me quickly see what all we can cover on those lines. The first one would be the data privacy and security. Of course, you have a challenge. You have massive data sets. You have vehicle telemetry. You have driver behavior. That's all on the fly. You have the risk of data leaks, cyber threats, unauthorized access. And of course, you need to be GDPR compliant and other things. What are the possible solutions? You have to implement secure data pipelines, federated learning, and you should ensure that robust encryption and authentication mechanisms are there. Ensure compliant to your global privacy regulation standards. Tesla and Waymo, in fact, have got, when they actually put this in market, they do have, and it's not just limited to Tesla and Waymo, most of the organizations actually put it across the AI architecture to be user data from the cyber threats, right? You need to protect your data from these threats. The next one we see is the ethical and bias. This is another problem statement that we see. GenAI models can inherit bias from large amount of training data. And ethical dilemmas in terms of, okay, when you have an ADAS and autonomous decision making, whom do you protect actually in the case of unavoidable accident? The answer or the solution lies in AI models must be transparent, explainable, and auditable. There's a concept called explainability, which is getting into the system. People want to ensure that these are all in place before the systems are approved. Implement diverse real-world data for AI training, and don't just go by one region specific. You have to give more data and specific to get the things working. And also employ the ethical AI governance framework. You have standard bodies like NHTSA, EU regulations now emphasizing explainability and fairness in AI-driven automotive systems. This is to ensure that the ethical and bias-related challenges are taken care of. The third one is in terms of reliability and safety. You have the challenges that, of course, you have generated code and test case. Are they reliable for safety-critical applications? Automotive software must comply to the safety compliance, which means that the code that you generate has to have the compliance in part of it. And what's the solution? AI-generated code should be human-verified, regression tested. That's the only approach that right now we should ensure. And hybrid approach, right? You have an AI-assisted, but human-supervised safety validation that is in place. And you have automotive platforms. Anyone that you take, right? They take safety as paramount. A lot of rigorous safety testing happens before they get deployed. The last one is the domain-specific training. And the challenge over here is, okay, you have off-the-shelf GenAI models trained on general data set, which is not automotive specific, and need for highly specialized domain-adapted AI models. The possible solution is, of course, develop custom-trained models using proprietary data sets, fine-tune these LLMs kind of thing. Now, we stand at an intersection of the AI and automotive innovation. One thing is clear. Generative AI is not just an enhancement. It's going to be a revolution. And there's a saying, right? With greater power comes greater responsibility. As we embrace GenAI, we must ensure that it aligns with safety, security, sustainability, because innovation without trust is just meaningless. With that, I conclude my presentation. Thank you very much for your time.
Thank you very much, Sujeet. We are a little bit behind schedule, but still I want to give the opportunity. If there are any questions from the audience, you have now the chance to raise your hand and get the microphone. And if that's not the case, we'll say another big thank you.
Thank you very much for that.
And coming up next will be the experts panel. Yes, give us 2 minutes to prepare the stage.